Go you. Alright, so let's see if we can do these all based off of those rules. So here, to know if a graph opens up or down, if your A value is greater than 0, it opens up. If your A value is less than 0, it opens down. So our A value, we have 1x squared plus 2x. So our A value is 1, so it opens up. Our vertex, we're going to find by putting this into vertex form. So we're going to have to complete our little box. So we got x squared. This time, since A was 1, we don't have to do all that crazy jazz that we did last time. We want 2x, so we want 1x and 1x. So that makes for 1 as our constant there. So our area model shows x squared plus 2x, yay, go us, plus 1. But we don't want it to have plus 1, so we got to subtract 1. So our vertex form is x plus 1, quantity squared, minus 1. So from there you can tell what the vertex is. Your vertex is -1 and -1. It's the opposite of what is inside of here, going along with our transformations, and it is just that value for your y. For our axis of symmetry, what the axis of symmetry does, it's not x-axis, y-axis, or origin, but what it does is if we have a graph of parabola, every parabola has an axis of symmetry where it folds in half. Our axis of symmetry is located at the vertex, and it's a vertical line, so it's always going to be x equals, and it will be whatever the x value of your vertex was. So that's how we got that. It has to be written as x equals, or I will count it wrong. Your vertex has to be written as an ordered pair, or I will count it wrong. So watch that. All right, for y-intercept, we've done this before. For our y-intercept, we plug in 0 for x. You can plug into your original equation or to your vertex form. I would plug into the original. You plug in 0, and so you get y equals 0. Do you leave it like that? No! You put it as an ordered pair. Please and thanks. All right, for our x-intercepts, we put 0 in for y. Since it is quadratic, you can do two things, quadratic formula or factor. I'm going to factor, so I get x and x plus 2. So the x1 gets me 0, 0, and the x plus 2 gets me -2, 0. For the domain of any quadratic is -infinity to infinity. The range. Let's look at a graph before we go and try and find our range. So, if we try to graph this, let's graph it over here. We have a vertex of -1, -1. And we say our intercepts are 0, 0, and -2, 0. So I plot all those dots. And I put my graph going up because it was concave up. So, and I draw my axis of symmetry. Yeah, go me. That was at x equals -1. So my range. Is my graph ever going to be down here? No. So your range is from the vertex y value upward. So we're going to start at -1, and we're going to go to infinity. Does it include -1? Yes, there is no open circle there, so it's a bracket. Watch that. So now we got to determine when our graph is increasing and when our graph is decreasing. You read a graph from left to right. This graph is not always increasing. Yes, this graph is going up, but that doesn't mean it's increasing. So from left to right, if you put your finger on the left part of your graph, it has to go down to trace. So this part is decreasing. So I'm going to say decreasing from -infinity to the x value of the vertex, which is -1. It doesn't include -1 because we're going to say it increases then from -1 to infinity. So you can't put a bracket because you can't put it under decreasing and increasing at the same time. And there you go. You got it all. So let's try another one. So, -2x squared plus 2x minus 3. See if you can do this one on your own. Alright, so hopefully you've unpaused the video and you have said that it opens down because it's -2. A is -2. Your vertex, we're going to put it in vertex form. So we take out -2 we have our area model here. We're going to have x squared still, so x and x. We divide 2x by negative 2 and get negative 1. So I want negative 1 in my diagonal boxes together. So I get a negative half x and a negative half x in each of those. You can't read this because I'm writing too small. Alright, so we have x minus a half and x minus a half, so we get a fourth in our box. So, can we find the difference in our constants from there? No, we have to distribute that to our area model. So we got negative 2x squared, yes, go us. We have negative 1x here times negative 2 is a positive 2x, yes, go us. We have a fourth times negative 2, which is a negative half. So the difference in the 2 is negative 2 and a half. So our vertex form would look like y equals negative 2 times the quantity x minus a half squared minus 2 and a half. I'm going to write that here. So y equals negative 2 times x minus a half squared minus 2 and a half. So your vertex is a positive half and negative 2 and a half. Your axis of symmetry is your x value, so x equals a half. Your y-intercept, plug in 0 for x and you get negative 3. So 0, negative 3. For your x-intercept, you plug in 0 for y. So if I plug 0 in for y, I'm going to do the quadratic formula on this one. So negative b plus or minus b squared minus 4 times a times c all divided by 2 times a. And I can see that there are no x-intercepts. Another thing that I can check is if I plot my vertex. So I go over a half and down 2 and a half. And my graph opens down, and I plot my y-intercept. Is it going to cross the x-axis? No. So I did that right. So let's go ahead and do our axis of symmetry while we're graphing. So our domain is always negative infinity to infinity. This time our range starts down below, so negative infinity, and comes up to our vertex, and our vertex's y value was negative 2 and a half, and it is a bracket because it's a closed dot. It is increasing at first, so negative infinity to the x value of a half, and a half to infinity. And you're done. There you go, you. Alright, let's try this last example. So pause the video, and unpause and see if you do it right. So you should say it opens up because A was 1. Your vertex. So we're going to put it in vertex form. We don't have to have an A other than 1. So you get 3x and 3x and 9. So x plus 3, x plus 3. So the difference in our constants is 0. So vertex form is y equals x plus 3, quantity squared, plus 0 if you want to put plus 0. So your vertex is negative 3, 0. Your axis of symmetry is x equals negative 3, because that is your x value of your vertex. Your y-intercept, plug 0 in for x, so you get 9. For your x-intercepts, put in 0 for y and factor or quadratic formula. Well, I'm going to factor because it's x plus 3 and x plus 3. How's our vertex form? It's actually our vertex. So you get negative 3, 0 for your x-intercept. So if we go to graph our x-intercept and our y-intercept, and we draw our parabola, and we draw our axis of symmetry, beautiful. So our domain, negative infinity to infinity. Our range is our vertex up. So our vertex's x value was 0 on to infinity. And 0 is a closed dot, so it's including. We're increasing at the end. So from negative 3 of an x value to infinity, and decreasing from negative infinity to negative 3. So, all right. And you are done. So that using for quadratics. So make sure you can get it into vertex form. That is key. If you're struggling with that, please come with questions for next time so that we can work on that.